Assalamualaikum and hi, my name is Nur Atika. MEMS thermal sensor. The operating principle of the design MEMS thermal sensor is thermal anomalometry provide the most basic structure and the largest range of flow rate measuring capabilities. The flow velocity is measured by utilizing the cooling effect of forced convection heat transfer to the air flow created by the heater. When the heater acts as the flow velocity sensor, a constant temperature circuit incorporates a feedback control to shorten the response time. The relationship between the flow velocity and electrical energy supplied to the heater under the forced convection heat transfer condition can be expressed as the first equation, where P is the electrical energy supplied to the heater, delta T is the temperature difference between the heater and the air, and G naught, K and N are constant, U is the average flow velocity. The equation is translated by using the applied voltage to the heater as second equation, where V is the applied voltage to the heater, A, B and N are constant depending on the heater structure.
Assalamualaikum and salam sejahtera. My name is Dunia binti Abdul Razak. For my part, I will explain about the MEMS fabrication simulation. For the layout, we are using 4 layers with 5 materials. The materials are polysilicon, silicon dioxide, gold and also copper. We are also using silicon nitride as a sacrificial layer. As shown in the slide, there's the material database, which is the elastic moduli, mass density, and also major and also the minor portion ratio for the polysilicon, silicon dioxide, silicon nitride, gold, and also copper. For this slide, I will present about the MEMS fabrication simulation. For our project, we start with wafer and then deposit the copper, etching the copper, deposit silicon nitride as a sacrificial layer, and then etching the silicon nitride, deposit silicon dioxide, etching silicon nitride, and then proceed back with deposit the silicon nitride, proceed with etching silicon nitride, continue with deposit gold, and then etching gold, and lastly etching the silicon nitride. As the final 3D model will look like that, and also the cross-section picture with the equation B minus A.
Hello, hi, my name is Nina Nashanain and I will present about the MEMS finite element analysis. First, this is the analysis system. We have connected the steady state thermal and the static structural to find the input-output, and the result we have looked at the static structural. Second, this is the design of our geometry. So this design we have drawn it in the space claim. So next one, this is the model of the that we have used. So for the input, we are using displacement, and for the output, we are using deformation. Next one, this is the picture of our design that have been meshed. Second one, this is the picture of our design for the input and boundary condition. So this is the second slide that I will present. This is the whole result that we get from this simulation. As you can see in this picture, this is the total deformation, and the red one is we have applied the displacement. So in this part, each of us using 5 different parameters, which is we are using 5 different material. So as I am using silicon as the material. So we can see the graph is increasing, as well as the other graphs. The other graph also increasing. So we can say that if we change the material, the value of the input displacement will always be increasing. And forget to say that the graph is the total deformation versus input displacement.
MEMS thermal sensor for campus sustainability. Thermal sensor is used in water heater in campus. The thermal sensor switch is installed in your gas water heater as a safety device. Block vents at the top and bottom of the water heater can cause excessive heat build-up inside the chamber and trip the thermal switch, shutting off the gas supply to the burner assembly. The inlet and outlet thermal sensor or temperature sensor work together to ensure the desired set temperature of the water heater is reached accurately. The cold water sensor is located in the water valve and the hot water sensor is clipped on the hot water outlet pipe.
Hi, my name is Fabrication, son of Nagesh. Today I am going to present about MEMS terminal sensor for campus sustainability. The United Nations Sustainable Development Goals chosen by our group is, the first one is clean water and sanitation, the second one is affordable and clean energy, the third one is responsible consumption and production. The water management is a comprehensive of environmental challenge. Improper water management will create numerous environmental problems such as water pollution, health issues, and shortages of natural resources. Smart water management is proposed by applying a MEMS terminal sensor. This terminal sensor solution will ensure safe and affordable drinking water, provide access to sanitation and hygiene, improve water quality, increase water use efficiency, and ensure fresh water supplies. Besides, this will create access to modern energy, increase of global percentage of renewable energy, double in improvement in energy efficiency. In fact, we can achieve the sustainable management and efficient use of natural resources.